video. I'll try to keep them to about 10 minutes a piece or so. See how much we can get in here. So number one, if you notice, this is x to the fourth and 7x squared. This is what's called quadratic form. So you can factor just like a quadratic. In order to make x to the fourth, we do x squared times x squared. And now you got to think a little bit about 18, 1 and 18, 3 and 6, or 9 and 2. And 9 and 2, if you notice, has a difference of 7. So I'm going to go 9 and 2. I need a minus 9 and a plus 2. Signs must be different to multiply to a negative. From there, I can actually factor this more if I want, or I can just go right into solving x squared equals 9, x squared equals negative 2. This side's easy. Square root gives you plus or minus 3. And this side, you got to think a little bit more. We get plus or minus the square root of negative 2, which, remember, the square root of a negative is an I. So we get plus or minus I root 2. Final answer, 4 solutions you should have expected. Negative 3, positive 3, and plus and minus I root 2. Moving on to number 2, determine which is a root of the following. So remember, in order to be a root, that means it is an x-intercept. So when I plug the value in, I should get 0 as a result. So I'm going to set up synthetic substitution. 1, 8, 1, and negative 42 are my coefficients. And I'm going to go through here and plug them in order. 2. So bring down the 1. Multiply, add, multiply, add, multiply, add. I get 0. Synthetic substitution then tells me that 2 is the solution. Number 3 here. Let's see, let p of x equal that quartic polynomial. Find all roots of p of x given that 3i is a solution, is a root. So if 3i is a root, remember they come in conjugate pairs. That implies that negative 3i is a root. So right off the bat, b is out. Right? There's no positive negative 3i. In fact, c is also out. So I really have 2 to choose from here. And looking at them, and this is the benefit of multiple choice, they both contain positive and negative 3i's and the 1's. So guess what? I'm going to do synthetic substitution again. 1, negative 5, 13, negative 45, and 36. And I'm going to plug in 4 or negative 4. I'm going to stick with the positive one here. And if it doesn't work, my answer is this one. So 1, 4, negative 1, negative 4, 9, positive 36, which gives me negative 9, which gives me negative 36, which gives me 0. Solution. Solution is D because I chose 4 and 4 did work. Solution is D for that one. And again, I mean, there's options here. If you know plus and minus 3i are roots, that means they came from x minus 3i, right? That's where positive 3i came from. And x plus 3i, that's where negative 3i came from. Okay, and then multiply that through, you get x squared. Middle terms cancel out, and you get minus 9i squared. Well, remember, I squared is negative 1, so that's really x squared plus 9. Okay, and from there you could do long division in here, and again, we got the answer, but we're going to go another route here. So x squared plus 9, and we have x to the fourth minus 5x cubed plus 13x squared. It's going to be tight. 45x plus 36. And long division says, well, x squared goes in here, x squared times. We multiply by this guy, and we get x to the fourth plus 9x squared. I'm going to line them up underneath their like terms. Those cancel out. Remember, this is subtraction here. I bring down the negative 5x cubed. 13 minus 9, that gives me a 4x squared. And I'll bring down my 45x. And then I say x squared goes into here minus 5x times. And I take minus 5x and I multiply. There's my negative 5x cubed. And a minus 45x again. Make sure they line up with like terms. And remember, we're subtracting, so these guys cancel out. Bring down my 4x squared. Oh, they cancel out nicely too, so now I bring down the plus 36, and I'm running out of space, so it's not going to quite line up. But remember, we brought this down to here, and this one came down as well. And now it goes in plus 4 times. You can clearly see it's going to go in evenly. Remember, we're subtracting, you get nothing left. And now you have this nice little quadratic, which you then know factors into x minus 4 and x minus 1. And you can see that 1 and 4 are your other two solutions. So again, multiple choice, you can take this way and kind of understand what the answers mean. Or if it's not multiple choice, you got to show your work, you're going this route here. Okay, so a couple different options there. Find the equation for the inverse of the following. Well, inverse, we're to switch an x and y. So instead of saying y equals that, I'm going to say x equals the square root of y plus 1. I'll square both sides. X squared equals y plus 1. And then I'll subtract 1. X squared minus 1 equals y. And remember, officially, this is now y inverse because we switched them. Okay, so which one, x squared minus 1, looks like is D. Determine which relation is symmetric with the line y equals x. Well, if it has y equals x symmetry, that means I can switch x and y and it will remain the same. So just real quickly, 2x squared and 5y squared, if I switch them, I have 2y squared equals 4 minus 5x squared. So think about that. If I add over here, I get 5x squared equals 4 minus 2y squared. Not the same equation. Over here, they both have 2's. That's a start. So 2y squared equals 4 plus 2x squared. And I'm going to get negative and negative, and this is not going to change. So no, these guys, so far they're both out. I want to go around the horn here. 2y squared equals 4 minus 2x squared. So I'm going to add 2x squared, check, and subtract 2y squared, and the 4 remains the same. We're good. Golden, letter D it is. Okay, so there is 1 through 5, and I think I'm going to do these a page at a time. We will call that a session here. 1 through 5 are done. Look for part 2 for the next page.